So my name is McLeod. I work at Mosaic Sales Solutions, a marketing agency. I mostly code in Ruby for that, but for a better part of a year and a half, I've started coding games. I have to confess that I started off using Java, and I eventually moved up into HTML5 and JavaScript for doing it. So yeah, I'm just going to kind of go over more or less HTML5 as a platform and as opposed to how to code a game. There's a lot of good resources out there already for that. So we're going to talk about the benefits, the downsides, whether you should be using Cannabis or WebGL, a little bit about audio, some performance tips, tooling, so things like game engines, compilers like Emscripten a bit, stuff like that, and then a little bit of tips on getting started and things that I found have helped me progress over the years, or year and a half. All right, so the benefits. Some of these are pretty straight obvious to us web guys and ladies, but the thing is that since we've been able to start building even static web pages, the fact is that we can reach everybody really easily across the globe. You know, we're at a lot different state now when we start publishing web apps and stuff, and even if you're building something internally for your company, you don't have to worry about someone down the hall who has a 10-year-old version of something or whatever. Every time someone visits a website, they're always seeing the latest stuff. And so now that we can do games in the web, we get the same benefit. We can deliver games to people around the globe. They can see it instantly. The next time they come, you'll make sure they get the latest stuff. It's really awesome. And of course, another benefit with that is different devices. So many of the devices that we use today have a web browser built in them. And so therefore, if you have a game at a URL, people can visit it there on your phone, and hopefully they can run it. And obviously, there's a lot of caveats with this. We still have to deal with things with all the different device sizes and resolutions and that. There's a lot of things to be considered there. But even if you're building like a native iOS and Android app, you still have to consider those resolutions. So hopefully the web can try and alleviate some of these things. And yay, JavaScript. So, you know, we can start using that to build games as well. You know, a lot of people who come out of college, and I see this on community sites, hey, should I start learning C++ and that? And often that is the case if you want to get a job at a AAA games company. But, you know, for those of us who are more comfortable with web-based languages, we can start to use to build something like that. Like, can we do something like a Crysis 3? Maybe not, but I mean, you can still build games that you want to, and you know, things that are fun, like a lot of indie games, and you know, there's even more and more impressive stuff coming out all the time. So the downsides. All right, so monetization is definitely a tricky one. Users play a lot of web games for free. I mean, think about all the ones you've probably tried over the years, like whether you've maybe played a bit of Farmville or Candy Crush is mostly free. Like these kind of things have microtransaction in that, but because of the market that the users are used to, it can be really tricky to sell your games. So that is a downside when you want to distribute for the web. You can, of course, start using things if you want to deliver to mobile, like Trig.io, PhoneGap, and I'll talk about another tool later, if you want to distribute like a native app, and that way you can take advantage of Google Play Store, the App Store, that kind of thing. So performance, especially with JavaScript, is definitely another kind of setback. We're not getting anything like we're getting with C++ or any of that. But as we all know, it's been really improving over the years. Browsers have gotten faster. Our mobile devices have gotten significantly faster even in the last 2 or 3 years. So this is improving. But you know, it's still something we have to keep in mind. You want to obviously set your scope right for the targets you want to set. So whether you're delivering to mobile devices or just even a regular browser on a desktop, on a desktop, you want to make sure that everything runs smoothly for your users. So Canvas or WebGL, and this, to sum it up, it really kind of depends on what devices you want to target and what kind of game you want to make. So to kind of first talk about performance differences, for the most part, they're actually kind of similar. It depends on what limits you start pushing. So typically speaking, WebGL is kind of more built for this sort of thing. So offhand, it's usually a good idea to go. But at the same time, I did a test here, and this is just a really simple demo of just some images translating across the screen. So this is using a canvas renderer, and As you can see, I mean, it's my MacBook Air, so it has a decent processor, but I'm getting roughly about 60 frames per second. And then when I take off the Cannabis hashtag, this is now using WebGL renderer, and I'm also getting 60 frames per second. So, I mean, this isn't really a good test. And when I tried this on mobile as well, I was getting lower frames per second, like roughly about 25 to 30, but they also still margin the same. So it's really when you want to start pushing the limits and taking things further. So this is a YouTube video, and I really apologize about the quality. But this is using the Pix.js renderer, and this implements sprite batching on WebGL, and that runs pretty damn good. I used a demo they put and ran it on my Android phone in Chrome, which supports WebGL now, and I was getting about 3,000 sprites loading on the screen, and they were bouncing around like crazy, and it was running great. So this kind of thing is really starting to advance forward very quickly. So, reasons to use the Canvas. First one, super easy drawing API. So, the difference here is with WebGL is it's really good at drawing things like images to the screen, but if you need to do something a little bit different, if you want to dynamically draw something on the screen that really can be any sort of shape, the Canvas API is really easy to do that. So this was like a little demo I made for actually just playing with the device motion API. But as you can see on the side there, there's kind of the tan lines that are angled. That's actually randomly generated. And actually, to be honest, there's no images on this screen whatsoever. The ball there is just a simple gradient with a sphere. The background color is just a simple square. And then the white thing in the middle is a shape drawn by using paths on the Canvas API. So this is a really simple, and I can roll here, and if I collide into an end, it restarts. So, but yeah, that's like a simple example, and you can do much more interesting things with it as well. So another benefit is it's super easy to scale it. Much like SVG, when you have a specified size, even if you set the scaling flag on the canvas, it tends to look pretty okay with the drawing API. Or if you want to get really fancy, you can use like a modifier variable. So if you wanted to, support like an iPhone at 960 by 640, or a desktop at 1080p resolution, you can say, oh, I know the size difference ratio, so let's just change my modifier and then affect everything across my entire game. And then so that way when you're drawing with the Canvas API, you can essentially cover all that. The problem is, though, it is typically more expensive. So you do have to be careful on where you're using it, but it's good to know that the feature is available. So definitely better support across devices is a big one. WebGL doesn't run on iOS, for example. And for Android, it's pretty new. Like if you're looking at a little bit older devices, you'll probably have a bit trouble running it. So if you really want to support a wider range of devices, having a Canvas target is really good. So the benefits of WebGL. I kind of covered this one pretty well, but it's faster. So you can do more amazing stuff with it and kind of push the limits of your game a lot more. More advanced features like the GL shading language. So this is when you can kind of get into things like fancy lighting, filters. You can do all sorts of different things with textures and that sort of thing. So it's really powerful in that regard. And also, it's pretty much your only option for 3D. Libraries like Three.js do have a Canvas renderer, but if you look at their examples compared to the same example in WebGL, WebGL just looks better. It's able to do more with its lighting. It's able to run more high polygon shapes and stuff like that. Really, if you want to do 3D, please do not use the Canvas. You're going to run into a whole bunch of bottleneck issues and stuff, so I really recommend using WebGL there. So, kind of talking about scaling again, I was working on a game where I have a snowball that kind of rolls down a hill, and the idea is that it collides into things and gets bigger, so kind of like Kaminari. And at first I was approaching it by drawing an image with roughly the max size I thought it would be, and I would just scale it down to the start and scale it up differently, and really it looked like shit. I mean, it just was not a good experience. I'm like, so this isn't gonna work. I actually ended up using the Canvas API for drawing the snowball, and that worked out pretty well. But to kind of show you how images scale a little bit differently in Canvas and WebGL, I'm gonna show you something. So this is an image I have here. This is properly to scale. It's 1024 by 768. So this is a quarter of the size image scaled up on the canvas. So as we can see, we have a lot of aliasing here going on when the colors really change. So we have this red branch over top of the yellow sky. It's really noticeable. Here on this vegetation, it's quite noticeable. But when we go to WebGL, it still doesn't look the greatest, but the blending is there. So basically it provides pixel blending between colors a lot better. And it still doesn't look great, but this is something you can kind of use to your advantage. So if you want to improve performance by rendering some low-res textures in parts of the screen where maybe the user's eye focuses, you can still kind of make things look a little bit better than you can on the canvas. So, all right, so audio. This is was definitely a hard point for a while. And even, not this year, but last year at Global Game Jam back in January, when I was working on an HTML5 game there, some guys had asked me, well, what about audio? And the library I was using had audio support, and it basically used the audio tag implementation API, but that has some drawbacks. So like, let's say you store 2 separate audio objects for 2 different sounds. You play one, you stop it, and want to play another right after, like just 3 JavaScript calls. There's actually a slight pause between them, and that's really, really difficult to get rid of. What you can do, though, is use the Web Audio API, and this actually really helps to eliminate a lot of those problems. I've been testing it more on things like mobile, and it works really, really great. There's actually a library out there called Howler.js, and it's really, really awesome. If you actually want to use any form of audio, like not even talking about games, definitely look at that. And the other thing too is it has fancy things like positional audio. So if you want to do like a sound that's like over here, like some sort of scary monster going ah, and you want it to come from the left or whatever, that's actually a really nice option. It has a lot of other little neat things too. I have to admit I haven't played with those as much, but it's good to know that the features are there. So under performance tips. So basically, the little things add up, and this goes in both directions. So every little thing you do that's like, oh, I'll just create another anonymous function, or I'll just reset this array every loop or a game loop or whatever, like that stuff is going to really kill your performance over time. And likewise, everything you do in a positive direction will add up to better performance. So the first thing there is to really talk about garbage collection. So when you're writing a game in C or C++, the onus is basically on you, and you'll start noticing really quickly you have to write things like pointers and manage the heap memory and all that sort of thing. But with languages like Ruby, JavaScript, and all that, the garbage collection is kind of not really in front of us. Like, we're not really dealing with it directly. So in some cases, it can be hard to know how it exactly works. And the key thing to note here is when their garbage collection in the browser decides to pick up, it's basically stopped everything. Like, actually think about this garbage truck. Driving down the road, all you guys in your cars are behind it, everything's going great. It's like, oh, some garbage is on the side of the road. Brake, stop, everyone in their cars, which is like, your rendering code and all that is getting angry because it can't go anywhere until the garbage truck starts up again. So, I mean, that's just a real big problem. And basically, to run 60 frames per second, you have to do all your update and draw calls within 16 milliseconds. So that's really not a lot of time. So what you want to do is when your game loads or you're switching levels or that kind of like a transitional sort of period, that's when you want to start creating all your objects and loading things in memory. So set up your arrays, create your objects, use something fancy like entity pooling. So if you need to remove objects, you can do more of a reusing kind of system. So that way you're not deleting things, because otherwise if you start doing, resetting or emptying arrays or anything like that, using the new keyword in the middle of the game loop, you are going to hit pauses. And this is something that can be really tricky to battle. I mean, I don't follow that rule 100% myself, and I do sometimes notice the issue, and it's something I'm trying to get better at, but it's really, really important to keep in mind when you start working on a game. So another thing to consider too is just deploying your traditional game dev optimizations. So this is whether you're coding a native game in C++ or you're coding something on the browser or using Flash or whatever. But the main thing is draw only what is on the screen. Do not make calls to draw something that is out of the viewport. It's completely pointless. I actually recently watched a talk by a developer at Sony who worked on the HTML5 interface for the PlayStation 4, and this was actually his first point on performance. He found with their WebGL calls, they were really hitting down performance by drawing things that weren't necessary. So like, thinking something simple like Super Mario, you have one of the Goomba mushroom guys, there's really not a sense in calling his draw call, image this position here if he's off the screen. Just don't. And when possible, only update objects on the screen. And what I mean by update is kind of processing any information for them. So back to the Goomba, he has this little walking animation. You know, when the time is passing in your game loop, you're getting a delta time back or whatever. You know, the idea is to pass that and use it to update the animation. No sense in doing those calculations if you're not going to use them and draw it to the screen. So things like that, obviously you won't be able to always follow that rule. There will be cases where, you know, you want one of the green turtles walking back and forth off the screen, so he needs to update accordingly, and that's cool. But just try and minimize it. That's basically the point I'm trying to get across here. Also, limit heavy calculations. So, like with Mario, for example, he obviously, you know, he lands on the ground, he collides with enemies and stuff on the screen, but you don't want to constantly check against every object and every tile in the level for every frame. Did he collide? Did he collide? Because that's going to be really heavy. So try and use really clever algorithms and stuff like that to minimize the amount of like collision detection and really other heavy calculations. So on to tooling. So still with the talk about performance, I'm just going to mention ASMJS and Emscripten a bit. Does anyone not know what ASMJS is? Cool, I was hoping a few of you wouldn't. So to talk about it a bit, so I'll say this quote first, but this is from the spec. So the whole idea is it's built around like integer and floating point arithmetic, and it basically has its own virtual heap as a typed array. So the idea is that it's a very, very subset of JavaScript that's performant. So basically, it's very, very limited. It makes a lot of assumptions about your code in the sense that it won't do garbage collection for you. You know, you can't really do all these things with fancy objects and stuff. It's really, really basic. So what you get is something more like this. So heap32 is a typed array of int32, and the idea is that you're essentially using bitwise operators to ensure that the integer that's getting passed into it is int32. And so basically the whole code set is like this. You can actually look up online to see what ASMJS compiled looks like. It's pretty ugly, so it's not something you want to code by hand, but that's where Emscripten comes in. So the whole idea is it's an LLVM to JavaScript compiler. So you can take like a C program, like even like a really simple int main hello world, and run it through the Emscripten compiler, and you'll get an like a JS out file. So that'll be a file you can run right in the browser. It also has compile options for generating you an HTML file and nice little things like that. But of course, you can start taking this to even further levels. So you can start implementing libraries like SDL, using OpenGL, and stuff to start coding like a full-on game. So the languages it says it support, I have not played with much of the scripting languages. I mostly used a lot of their examples with C and C++. But it does have support for a variety of languages there. So I think, you know, if there is something you're interested in really trying out, maybe try playing with a bit and see if you like it or not, or if it works for you. I'm sorry, I just don't know the details on how well they're all implemented. Another, not really an option here, but kind of an interesting way people are taking this is there's a library out there called low-level JavaScript, and this essentially runs on both Node and SpiderMonkey. And it's a very, very C-like language where you have things like structs and pointers and just basic functions. So the idea is you can write code in like this, run it through their compiler, and you get output like this. So this is more of the base library, and it uses its own sort of memory management system. The idea is for, you know, kind of back to my talk about garbage collection where you create all your objects and stuff you need ahead of time. That's basically how it tries to handle things. There is also a fork of LLJS done by a Mozilla developer who actually has it to compile to full-on ASMJS, but there's a lot of important missing features, such as it actually doesn't have any support right now for dynamic memory allocation. So that's like a big setback. Really, I just think this kind of thing is neat to pay attention to right now. It's not something I would really recommend for actually really coding something. Like, you know, if you have an afternoon and you feel like experimenting, like it might be something worth trying out. But for LLJS, I would not really use it for anything serious. So my thoughts on Emscripten as a whole. Because it's really meant for kind of a compiler target point for C++ and that, I think that's what it's really good for. So if you're coding a desktop game, or you're a shop that wants to convert a game over to on the web, this is a really great opportunity for that. It can also be really good for things like if you have a heavier bit of code in your game that you want to move out and make it really performant, code it in a lower level language and then compile it using that. And then that way you can get this chunk of performant code functions, and then you write your regular game logic in fun JavaScript and just execute those functions as you need to. So some of you may have seen this already. I'm just going to show you a short bit of it. But when ASMJS came out, this was a demo that they showed with the Unreal Engine, and it's basically a full 3D environment. You can walk around like it in this. It runs pretty well on both Firefox and Chrome, probably Safari, I can't quite remember. But yeah, so you have a full 3D environment that's fully textured and lit, and it runs pretty great. And like this kind of thing is really cool. Like I think it kind of shows what we can do with these tools, and that there are options out there. And if you have really any doubts about the web as for building games, you don't really need to. Okay, so earlier I kind of briefly mentioned using things like Trigger.io and PhoneGap for taking an HTML5 game and deploying it to things like the Play Store. CocoonJS is basically your best option for actually doing games. It actually does full-on support for building a regular app now, but initially it was always targeted towards games. So you get things like a hardware-accelerated canvas. It has WebGL support. So if you want to deploy a WebGL-based game to mobile, you can, and this is the way to do it. You just can't still deliver it in the browser quite reliably, but this is a way to do it. It also has support for really nice things like device motion, so what you get in the browser, you basically get there as well. You have controller and gamepad API support, so if you want to give that a little bit addition for somebody who's like an Xbox 360 controller, you can push to that. You also get things like ad support, in-app purchase, so you can basically build pretty much what you would want to using Objective-C or Java, but use the languages that we love. So I'm going to talk a little bit about engines. There's a lot of them, and some of them are not so great. There's a lot of great ones as well, but a few that have kind of caught my eye and some that I've been using. So Phaser uses the Pixie.js renderer, so you get both Cannabis and WebGL. WebGL is the main target, but it simply falls back to Canvas if the device doesn't support it. So you get a lot of your usual kind of things that you would with an engine. So you get physics, animation support, kind of sprite management. It does the game loop for you, so you just need to manage your own objects directly. And all that sort of stuff. Turbulence initially was a paid service, but they open sourced their SDK. And basically it has Canvas and WebGL. I believe it does support 3D and 2D. But it's a little more on the hardcore side. Like you get like a full-on build system and stuff with it. And I've played with it a bit, but I found it not really for me. But if you want something that's a little bit more full-on with, you generate projects, you do a build target output and all that sort of stuff, then maybe it's for you. The one I am currently using is Melon.js. It currently only has a Canvas renderer. It has a lot of the other stuff I talked about as well. This is just a rough featured list that really doesn't cover much of it. But it has animation support, object pooling, so the idea, instead of you worrying about the memory management stuff, hopefully this can kind of help you with it. Physics and math support, especially for different shapes. We've really been improving a lot of that lately, and with experimenting and developing towards a one-row release. It has texture packing, so you can optimize your images a lot better. Tiled map editor support, so if you want to do like a 2D leveling, you can just build your level in tiled, basically draw a box where you want your entities to go across the screen, and you do your bits of game logic and stuff in code, of course, but you can still do a lot of the graphical stuff through there at least. Screens and game states, some kind of different ways to organize things like a title, a pause screen, your main game, all that sort of stuff. Simplistic camera, so it can have follow your guy as he moves across the screen, so that you can get a side scroller going pretty quickly. There's also some pretty basic support for Spine, which is a skeletal animation app. And basically the whole idea is you have different pieces of, like let's say a human, you have an image for a hand, limb, and all that sort, and you attach it to a skeleton, and you use spine to kind of draw the more natural movement. We do have some basic support in MLJS for that as well. So how to get into games? Basically, the short answer is just get started. You want to start, check out an engine, play with some different ones, go through the tutorials, see what kind of works for you. But the key is also, just start building something, like do a Pong clone, step up to Tetris, do your own game. But if you do want to do your own thing, I really do recommend keeping the scope small, like any other side project. When you have a bigger scope, it's harder to really keep at it. You can get bogged down, you start hitting a lot of bugs, and it becomes demoralizing. You don't want to get stuck on that. So try and start small and work your way up. And there's actually a site I would recommend joining, and it's one I participated a lot in last year. It's called onegameamonth.com, and it has like a whole achievement system. So the idea is, as you're building games and you submit them, you kind of get points and that sort of a thing. You can browse games other people submitted. It has like a whole Twitter bot system that you can follow, so it's retweeting what people are talking about on Twitter. And so it's kind of like a bit of a community to kind of support each other as you're trying to build stuff and have fun with it. Basically, to sum things up, guys and ladies and everyone here, I just want to say that if you're interested in games, the web is definitely possible and you can do it. That's it.